NextPCB is a leading provider of reliable PCB fabrication and assembly services for engineers, startups, and businesses worldwide. Specializing in quick-turn prototypes to mass production, we offer multi-layer, HDI, flex, rigid flex, and metal core PCBs with strict quality control and superior customer care. Our advanced facilities ensure reliable performance for applications across consumer electronics, automotive, medical industries, and more. Embracing Industry 4.0 digitization, we streamline the entire electronics manufacturing process to give you competitive pricing and fast lead times, without compromising on quality. And our user-friendly online platform provides instant quotes, order tracking, and full transparency. In addition to PCB fabrication, NextPCB offers comprehensive PCB assembly services including global parts procurement, testing, certification, and box builds. Our 36 automated assembly lines include advanced inspection tools such as SPI, ALI, and X-ray, reflecting our commitment to quality and reliability. Choose NextPCB for exceptional electronics manufacturing solutions you can depend on.
You can see the NextPCB link by going to the More under this video. Click that, scroll down, and right here is check out our sponsor, NextPCB. Thank you. Now that we have a basic understanding. Welcome to GeeekPi Tech Talk 102, Geek Hub Introduction by LabRats Engineering. The focus of this video is GitHub and its installation. We will also compare what Git has in common with GitHub. Git and GitHub are closely related tools used in software development, but they serve different roles in managing and collaborating on source code. Git, a distributed version control system used to track and manage code changes locally with features like branching and merging. But GitHub is a web-based cloud platform that hosts Git repositories and enables collaboration through pull, request, issue, and team management. We can see that Git is a software tool where GitHub is a service. Git provides command line support through a terminal, and GitHub provides an attractive interface, GUI, to interact with the Git repositories. Get my mouse to work correctly. Git is installed locally on your system, whereas GitHub is hosted on the web. Git focused on a version control and coding sharing, where GitHub is focused on centralized source code hosting. Git is maintained by Linux, and GitHub is owned and maintained by Microsoft. Git is an open source. No one owns it. Here is a video tutorial over GitHub and Git that is really good. It's one of the best I've seen, so I've included it here. Review this and then go onto her webpage, please, and hit like and subscribe. She has many tutorials, coding tutorials. She is the coder's coder.
If you're learning to code, you've probably heard of Git and GitHub. These are some must-know tools for any web developer, but they're not the easiest thing to learn. They have concepts that are honestly hard to get the first time around. Commits, branches, merging, pull requests, and other things. If you're having a hard time getting Git, don't worry. I'm going to demystify Git and GitHub. I'll show you the basics step by step, from installing them on your computer to tracking your code changes. Git and GitHub will make your life as a coder much easier, and they'll look good on your resume as well. So let's get into it. To start off, what is Git? Git is a type of software called a version control system, which tracks changes to files. What this means is that it'll detect all your code changes, and you can use it to record different versions of your files at different points in time. This is super helpful for developers for a number of reasons. For starters, having Git is kind of like having a giant set of save points. If you make a code change that you realize later on was a huge mistake, you can revert back to an older version of that file. Git also makes working on a team a lot easier. Each developer can work on a copy of the project on their own computer. This copy is stored in a folder connected to Git, which is called a local repository. The developers can then send their code changes up to the main remote repository, which is stored online, and get code changes made by other developers. The most popular place to store your remote repository is GitHub, which is owned by Microsoft and is free to use. If you don't have a GitHub account yet, you can go to github.com and sign up for a new account for free. Once you're signed up, we're going to use the GitHub desktop app to run GitHub on our computer. To download it, go to desktop.github.com and download and install the program. Now, I just want to take a minute to explain the differences between Git, GitHub, and GitHub Desktop, because it can get kind of confusing. So Git is the actual version control software. It was originally meant to run on the command line, and a lot of developers still run Git this way. GitHub Desktop is a program that runs Git on your computer and allows you to do most of the Git command line commands just through a more graphical interface. And a quick note, I know a lot of people like using the command line to run Git commands, but for beginners, I've always felt that it's a little easier to use a tool like GitHub Desktop. So if you're already familiar with Git and GitHub, you can, of course, use whichever tool you prefer. Lastly, GitHub is a website where you can host your Git repositories. You can also collaborate with other users and discover other open source repositories. Okay, so back to the GitHub desktop app. Once you've installed the app, go ahead and run it. Now, the first thing you'll want to do in GitHub Desktop is to sign in to your GitHub account. Go to File, Options, and in the Accounts tab, click the Sign In button. This will prompt you to sign in using your browser, so go ahead and click Continue with Browser. Your default browser on your computer will try to log in to your GitHub account. So log into GitHub if it's prompting you to, and if you get a pop-up window that says choose an application to open the GitHub Desktop auth link, make sure that GitHub Desktop is selected. Once you're signed in, your computer should go back to GitHub Desktop. And to make sure that everything worked, go back to File, Options, Accounts, and you should see your GitHub username and profile picture on the right side. Now, we want to set our global Git configuration. In the options, go to the Git tab, and you should see your GitHub username listed under Name and a user's no-reply-github.com email under Email. Then under Default Branch, select either Main or Master. Master used to be the default branch on Git, but currently GitHub and other places are using Main as a default, and it's what I use as well. Once your settings are set, make sure to click the Save button, even if you didn't make any changes on this screen. GitHub Desktop will automatically populate these fields when you log in, but you still need to manually save them. Now, we're going to walk through the basics of a Git workflow with a test project, so feel free to follow along. So first off, we want to create our repository. Go to File, New Repository, and then in the name field, write the name of your test project. GitHub repos need to be named a string without spaces, so usually you'd use hyphens between words. For example, I'll be naming this test-repo. The description field will let people who see your repository on GitHub know what it's all about. The local path is a folder where you want to create your repository. I use Windows and generally put my repos in the Documents GitHub folder, but you can choose another location if you prefer. Then check the box asking if you want to initialize this repository with a README file. This file lets you write a more detailed description about your project that will show up on GitHub, and you can always edit it later. This is optional, but in general, it's a pretty good idea to have one. The Git Ignore field lets you select types of files that you don't want to add to the repository. I usually leave this at none and then ignore files later on while I'm coding, and we'll get to this later in the video. The license field tells people what they are allowed to do with your code in the repository. Since a lot of open source exists on GitHub, most people select the MIT license, which allows people to copy, distribute, and modify your code. If you leave it blank, your project will be licensed with standard copyright. You can read more about open source licensing at choosealicense.com. Now, once all your options are selected, click Create Repository. It may take a few seconds, but GitHub Desktop should create and automatically load the new repository. Now let's take a look at the desktop app. At the top, under the menu bar, you'll see another bar with information about your repository. On the left is the current repository that's open. Next to it is what branch you're currently on. We'll talk a bit more later about working with branches, but for now, just know that a branch is one version of the codebase and you can have multiple branches. Then at the end, it tells you that you can publish this repository to GitHub, which we will do a little later on. Under the repository bar is the main panel, which has a left sidebar. The sidebar has two tabs. The first is a Changes tab. This is currently blank since we haven't added any files or made any code changes yet. And the History tab, which has an initial commit with the files generated by GitHub Desktop when we first created the repo. If you have the Changes tab selected, at the very bottom of the sidebar is the Commits panel. A commit is the save point that you can create during development that includes a set of code changes that you want to track. Let's start making some code changes to see what happens in Git. In your VS Code, go to File, Open Folder, and select the location where you created your GitHub repository. Now, if you see an alert message from VS Code saying Git not found, what this is doing is asking if you want to download the original version of Git that runs on the command line. You can either dismiss the alert, or if you think you might use Git on the command line at some point, you can click the Download Git button to download and install it. If you do decide to download and install Git for the command line, I'm going to show you the settings that I use for Git. Now, for most of the settings, I'll go with just whatever is pre-selected. But most importantly, for the default editor used by Git, I set that to VS Code instead of Vim because I like VS Code. And the other settings is for the name of the initial branch when you're making a new repo. I want to override the default branch name and use main. And for everything else, I just hit the next button and then finish installing. Now, let's create a new file. Click the new file icon in the left sidebar and create an index.html file. In the file, use an exclamation point and tab to use Emmet to create boilerplate HTML markup, and then save. When you go back to GitHub Desktop, you'll see in the left sidebar, under the Changes tab, will be the index.html file. And there's a green plus icon on the other side. This means Git has detected a new file and wants to add it to your repository and track any future changes. On the right panel, you'll see the actual code changes that you made in the file. Right now, we've added new code, which is why the lines of code are highlighted in green. You'll also see a checked checkbox to the left of the file name. Checking this box will stage the file, which means that you want to include this file change in your next commit. Now, let's create our commit to add the index.html file to the repository. In that bottom commit section, there's a field where you can add what we call a commit message describing what the change is. GitHub Desktop has automatically populated the field with text saying create index.html. You can keep this as your commit message or write your own. There's also a larger description field under it where you can optionally write a longer description if you need to. Then at the bottom is a button saying commit to main. This means that clicking it will create a commit on your main branch. This matches the current branch up at the top of the main panel. Click the button to create the commit. After we commit, the Changes tab is now empty. And if we click on the History tab on the left, we'll see that the commit that we just made, along with the code changes from that commit. You may have noticed up at the top on the right a panel that says Publish this repository to GitHub. Since we created this repository locally, it's not going to exist on GitHub until we publish it. So go ahead and click that button to publish. A window will pop up with the name of the repository and the description. And there's a checkbox for if you want to keep the repo private. Now, I'm just going to keep this private since it's not for any real code. Then click Publish Repository and it will get published to your GitHub account. Let's go to the GitHub website and see how our repository looks. If you go to github.com, log in if it prompts you to. Then click on your avatar in the top right and navigate to Your Repositories. When you see the test repo repository, click on that and it'll load. Now, let me point out a few things that are good to get familiar with. In the top left is your username, followed by a slash, then test repo. This tells you what repository you're currently in, and it'll also be listed in the URL. In the main part of the web page, GitHub will load the most recent commit message, which should be create index.html. And it has a 6-digit code that is the hash for that specific commit. So every time you create a commit, Git will automatically create a random hash, which is a long string of letters and numbers that serves as a unique ID for that commit. Now, if you click on the 6-digit code, it'll load that commit, and you can see the really long string in the URL and on the right side. Going back to the test repo repository, next to the hash is how long ago the commit was made. Then at the end is a total number of commits. Under the top bar, GitHub will also display the files currently in the repository, which right now is only the index.html file. As we add more files, you'll see them all in this area. And if you click on the file name, GitHub will load the actual code in that file. You can even edit and delete the file right in GitHub. I wouldn't actually recommend doing this since it's better to manage your code in VS Code, but it's nice that the access is there. We'll look at a few more things in GitHub in a little bit, but for now, let's go back to VS Code. So far, we've added files to our repository, but there might be files and folders that you create that you don't actually want to track in Git. So let's say you're keeping some notes or something in a text file called random.txt that's in your project. You want those notes there, but you don't want them to be public in your repository. In GitHub Desktop, what you can do is uncheck that box. That will make sure that the file won't be included in any commits. However, it can be kind of annoying to keep seeing that file name all the time. So you can actually have Git ignore files and folders. If you right-click the file and select Ignore File, Add to Git Ignore, you'll see that random.txt has disappeared, and there's a new file that Git has detected and wants to add to the repository, the .gitignore file. In the right panel, we can see that it contains random.txt. And if we look in VS Code and open the gitignore file, we'll see that random.txt line. In gitignore files, you can ignore individual files and folders by adding each one on a separate line. So let's test this out. In the gitignore file, add another line that says random123.txt and save. Then in VS Code, create a file with that file name. Going back to GitHub Desktop, you can see that it has not added the random123.txt file since we ignored it. Now, as you might imagine, it can get a bit tedious to have to manually write each file name in the gitignore file. One thing that can help with that is that you can use the wildcard symbol when writing the file name. So let's go back to the gitignore file and delete everything that's there. Then add wildcard.txt to ignore all text files. Now in GitHub Desktop, we don't have either of the text files showing up, and we can see the wildcard in the gitignore file. Just be very careful when using this to ignore file types, in case you might want to include a file of that type in the future sometime. Let's make a new commit with a commit message that says ignore text files. Then double check to make sure that the .gitignore file is checked and click commit to main. In the top right, we can see the panel saying push origin. What origin is it refers to the remote repository that we published on GitHub. So when we push commits in our local repo up to origin, they will get pushed to the origin repository, which is on our GitHub. So let's click push origin. It usually takes a few seconds. Now let's go back to GitHub and the main test repo repository page. We can see that it looks a bit different now. The most recent commit is the ignore text files one, and it has a new hash. And the total number of commits has also gone up. And we can see that the .gitignore file is now on GitHub too. So we've covered adding new files to the Git repository. Another thing Git will keep track of is changes made to existing files. So let's see how this looks. In VS Code, open the index.html file and let's add some content to the body. I'm adding an h1 tag with some text, hello, here's our website, and a paragraph tag saying, here's some cool new content. Save it, and let's see what this looks like in GitHub Desktop. Now, in the left sidebar, the index.html file is showing up, and instead of that green plus icon that we saw when adding new files, there's a yellow dot icon. This signifies that Git has detected modifications in that file. Then in the right panel, we can see the new text that we just added, and it's highlighted in green, meaning that it's code that has been added. So let's make a commit. I'll make the commit message something like added content to index.html. Now we'll commit it to the main branch and push to origin. So if we click on the history tab, we can see the 4 commits that we have in this repo, with the most recent on top. And if we go back to github.com to the repository page, we can see the same history up there if we click on the 4 commits link on the right side, again with the newest commits on top and the oldest ones on the bottom. Git will also track if you delete files, so let's test this out. In VS Code, go ahead and delete the index.html file. Going back to GitHub Desktop, we see that the index.html file is showing up under Changes. It has a red minus symbol icon to indicate that the file has been deleted. And in the right panel, all the code in the file is highlighted in red, meaning that it has been removed. So let's make a commit with a commit message saying that we deleted index.html. Commit it and then push to origin. If we check out GitHub, it'll show the most recent commit, and clicking on the commit, it tells us that the file was indeed deleted. But what if we realize that we really need that index.html file? Not to worry, this is one of the ways that Git can really save your life. In GitHub Desktop, in the History tab, right-click the commit where we deleted index.html and select Revert Changes in Commit. Now we can see that Git has automatically created a new commit saying that it has reverted the previous commit. And looking at more details in the right panel, it tells us that the hash of the commit that was reverted, and it's added back the index.html file. Whew! Now if we click the Push Origin button, everything will be back to normal. In VS Code, the index.html file will be back, and in GitHub, if we refresh, we can see the commit reverting it, and the index.html file is also back where it belongs. Now there is one more area in Git that I would like to cover, and that is branching. In Git, a branch is one version of the code base, and a repo can have multiple branches going at the same time. So far, all the work that we've done in Git and all the commits that we've made have been on the one main branch. Now, if you're just working by yourself, you can probably get away with doing everything on main. But if you're on a team with multiple developers all working on the same code base, it would be quite chaotic to have everyone working on the same branch, especially if more than one person makes changes to the same file. So most teams will separate work into different branches. You might have one developer fixing a bug on the homepage working in a branch called homepage bug. Then there might be another developer building a new feature on the careers page working in another branch called careers. Each of those branches will be created off the main branch, so they will have the most up-to-date code from main. Then they'll each work on their own branches locally. When the developers are done with their work, they will merge their branch back into the main branch. This type of workflow is considered best practice when you're working on a team. So even though in this course we can do all our work on the main branch, I wanted to show you a little bit of what working with different branches looks like. In GitHub Desktop, in the top menu, navigate to Branch, New Branch. Let's give it a name of Feature-1. And you'll notice under the name field is a note saying that the new branch will be based on the current branch, which is main. Then click Create Branch. Now, up at the top, GitHub Desktop has the Feature1 branch listed as our current branch. Let's make some demo code changes in this branch. In VS Code, create a new file called feature1.html to keep things simple. And in the file, hit exclamation point and enter to use the Emmet shortcut to add boilerplate HTML. Then save the file. Back in GitHub Desktop, we want to add feature1.html to our repo. In the commit panel at the bottom, we'll just leave that default commit message that they have and hit the button to commit this change to the feature1 branch. Now, in GitHub Desktop, let's switch our current branch back to the main branch. If we go back to VS Code, the feature1.html file won't exist. This is because it was created in the feature1 branch, and so it doesn't exist yet on the main branch. Git will keep the codebase files updated depending on what branch you're loading. So let's pretend that we've now finished all the development work on the feature1 branch and we want to deploy it to our website. We need to add our changes from the feature1 branch to the main branch in what's called a merge in Git. To merge feature1 into main, in GitHub Desktop, first make sure that you are currently in the main branch. Then in the top menu, navigate to Branch, Merge into Current Branch, and select the feature1 branch. So what this is saying is that we will merge all the commits from the feature1 branch into the main branch. Click the button saying Create a Merge Commit. This will merge in the code from feature1 into the main branch, and the change will be automatically put into a new commit on main. Now, if we load the History tab, we can see the Create Feature1.html commit message listed as the most recent commit on the main branch. Now click the Push Origin button up at the top to update GitHub. In GitHub, if we load the repository page, we can now see that the commit creating feature1.html is the most recent commit, and the file exists on the main branch. One last thing to note, if you're working on a team that uses GitHub, new branches are typically merged into the main branch through a feature on GitHub called pull requests. This allows other people on the team to check the code changes and approve them before merging them into main. This helps to prevent any mistakes from being added. So what you would do is make your code changes and commit onto the feature 1 branch. Then, instead of merging feature 1 into main in GitHub Desktop like we did last time, you would publish the feature 1 branch up to GitHub. Then on GitHub, you would create the pull request so that other people on your team can review and either approve or suggest code changes. If the changes are approved, your team member can then merge your changes into main. Again, this is mainly if you're on a team. We're not going to be working with multiple branches or pull requests in this course, but I wanted to make sure that you know that they exist because they are common practice when you're working on a team. And that's it for the basics of Git and GitHub. This video is actually from my course Responsive Design for Beginners. You can find out more info about it down in the description. If you like these explainer type videos, you might also enjoy my other video on NPM in 15 minutes. And as always, thanks for watching, and we'll see you in the next one.
Now that we have a basic understanding of GitHub from an excellent tutorial, it's time to install it on our computer. Click on the link on the laptop, select this link. This website will show. Select download for Windows 64-bit. You'll see it downloading right here. Once it completes, it'll write the executable to your download directory. We've already done that, so I'm not going to sit through this again. Open up your directory. Go to your download directory. This is it right here. I've done it several times, as you can see. Select it. And GitHub Desktop begins. Once this installation's done, it will open up. There's no way you can't alter it. Everything is default. All right, it's completed. This is what it looks like. In the next video, we'll learn how to connect our local repository to the repository that's on the GitHub in the cloud, our repository that we create. So let's move on and we'll get to this in the next video. So close that, close this. Now for the cool part. We're going to click on the link that's displayed on the screen. That's going to take us to the GitHub repository where our ultimate starter kit, all the software is already there. We've got a great manual right here, a good README file. We have the Arduino, the ESP32, the ESP8266 pinout of all the different chips, and the Raspberry Pi Pico. So come over to the big green button right here, select it, scroll down to download zip. As you can see right here, it's already completed. There is our file. This will be our local repository of all our software. So you want to Select that, install it, and unzip it wherever you're going to be, whatever directory you're going to name as your repository, and you're going to be working out of that. The next, please give Jessica Chan, aka the Coder's Coder, a like and subscribe. Here's her YouTube channel. This is her. She's very good. She has all kinds of, she has over 120 different videos to learn from. And you can also help us, excuse me, you can help us out at the Lab Rats. We're up late at night making these videos, and we need all the coffee we can get. So help replenish our coffee fund. Just select on this donation. This will come up. You can give anything you want. I think $1 is the least amount you can give. You can give it one time, monthly, or yearly. So please help us donate, and I hope you enjoyed the video. Thank you. Here at Lab Rats Engineering, NextPCB is our one-stop solution for PCB manufacturing, PCB assembly, and DFM analysis. They offer a wide range of high-quality PCB services, including multi-layer HDI, flex, rigid flex, and metal core PCBs. NextPCB also provides complete turnkey PCBA services from component sourcing to assembly and functional testing, ensuring precision, reliability, and fast turnaround, with express options available in as little as 24 hours. What I really like is their professional support, fast shipping, and consistent build quality. Their one-on-one engineering service also helps ensure your design is optimized for manufacturing. If you're getting started, NextPCB offers a $20 discount on your first PCB order, which is essentially enough to get your first PCB made for free. Use NextPCB as your comprehensive solution.